Yes, welcome to my channel, Mugambe Brian 256. So today we are going to continue from the characteristics of images formed by concave mirrors when the object is placed at different position. So last time we had looked at cases where the object was placed beyond the center of curvature and when the object was at the center of curvature. Then today we are going to continue, and that's when you have positioned the object at the focal point. So wherever the object is placed at the focal point, so these are the two guidelines that we shall use. So we are introducing in another guideline which says that a ray of light going through the center of curvature is reflected back in the same path. So wherever this ray of light goes through the center of curvature, it comes and strikes the mirror surface here, then it is reflected back. That's why you see that we have an arrow going, which is the incident ray, and then an arrow coming back, which is the reflected ray. Then another guideline is a ray of light that is very close and parallel to the principal axis is going to be reflected through the focal point. Now, we always have an image formed when two rays do meet, but in this particular case here, we see that the reflected ray is coming back, and also this ray that is passing through the focal point is also going like that. So we realize that in this particular case, the image of this object here O is going to be formed at infinity, at a point that we don't know, and it is going to be real and inverted, this other side down. Okay, the next case is when the object has been placed between the focal point or the principal focus F and the pole P. Let's see what happens. Okay, now when we have the object being placed between the focal point F and the pole of the mirror, so here is our object. Where do we expect the image to be, and which guidelines are we going to follow? So we shall have a ray of light going through the center of curvature. We said in this particular case, it is reflected back in the same path upon striking the mirror surface. Then another point is a ray of light that is close and parallel to this principal axis here is going to be reflected through the focal point. However, it will appear as if it is coming from behind the mirror. The same case will happen to this ray that is going through the center of curvature. So it appears as if it is coming from behind the mirror. That's why we use these dotted lines to indicate the apparent rays. And wherever we have two apparent rays meeting, so that's when you form a virtual image. And in this particular case, the image that is going to be formed, first of all, is going to be magnified. So we are able to see that the size of the object and the size of the image, in the way that the size of the image is bigger than that of the object. And the other characteristic is this image that has been formed is upright. It's upright, and then it's also virtual. Reason being, it is formed by the apparent intersection of light rays. I want to thank you so much for watching.